where we got to take the derivative. It's not a problem where we have to tell anything about increasing, decreasing. But this one's a little trickier than some of the ones you guys have done, so I do want to do it. So if we're taking the derivative of this, remember this is when every time we have a y, we have to put a dy dx whenever we take that derivative. So this first part requires the product rule. So I would have x squared times the derivative of y, so dy over dx, plus y times the derivative of x squared, which is 2x. So that's my derivative here. Then I have to use a quotient rule for x over y. So I would have to say y times the derivative of x, which is this 1, minus x times the derivative of y, which is dy dx, all over y squared, and that will equal 0. This one's a little different than the ones we've done before because we got this fraction over here, which is a pain. What I would do is, since you got the minus here, I would just move this whole fraction over to the other side. So you've got x squared dy over dx plus 2xy will equal y minus x dy over dx over y squared. And we cannot do anything with that y squared in the bottom because you can't solve for anything when you still have that fraction. So I would multiply both sides by y squared. And when you do that, make sure you got parentheses around this. You got to distribute here. So you get x squared y squared dy dx plus 2xy to the third will equal y minus x dy over dx. Once you get here, it's pretty much like the other problems. Move everything with a dy dx to the left side. Move everything else to the other side. I'm going to go ahead and factor out my dy dx here. So you'll have dy dx times x squared y squared. And this is going to be a positive x whenever you move this part right here over to this side. And that's going to equal y minus 2xy to the third. And so your last step is to divide by x squared y squared plus x squared y squared plus x. And that matches B over here. So B would be your answer. It's been a little while since we did these. What questions do you guys have on that one? You guys were pretty good at these. I remember when we did it. The only thing that some of you had trouble with was you would forget to use a product rule whenever you needed to, or quotient or something. But you guys were pretty good at those. Alright, so let's get rid of this. So let me that. Okay. Alright, let's look at number 2. Alright, so let C be the curve defined by x times y equals -4. Which of the following statements is true of the curve C at the point -2, 2? Okay, so A says something about a relative minimum because the y prime equals 0 and y double prime is positive. We have maximum, y prime is 0 and y double prime is negative. Increasing and concave up, and increasing and concave down. All 4 of these have something to do with both the first and second derivative, right? So Let's look at the first derivative. If we take our derivative, you have to use a product rule here. So you're going to have x times dy dx plus y times just 1 will equal 0. So you would move your y over to the other side. So x times dy dx would equal negative y, and then you divide off that x. So your dy dx would equal negative y over x. And we only care about the point negative 2, 2, because you can't really do sign lines when you have implicitly defined problems, because you have to worry about the x and the y. So you couldn't make yourself a number line for x that would be effective. So they'll always ask at a certain point, or at least in a quadrant. So if I plug in negative 2, 2, I would get our dy dx such that x equals, or negative 2, 2, I guess it should be xy equals. And so we would get negative 2 over negative 2, which is positive 1. So the first derivative is positive 1. That means a and b are out, because first derivative is positive 1. If you look at C and D, it tells us for both of these, if the first derivative is positive, that tells us that the curve is increasing. So both of these say increasing. So we're still going to have to find that second derivative. So for the second derivative here, you're going to take d squared y over dx squared. You're going to use quotient rule, so you'll have x times why is it not letting me write? There we go. X nerves. Alright. X times the derivative of y, which would be negative dy dx, which is the parentheses and that's times, minus negative y, so plus y times 1, all over x squared. And so you need to plug in negative 2, 2, and you already know the derivative at negative 2, 2, so you could just use that 1 and plug it in here. So you don't have to like replace anything there. So you could have negative 2 times, it's negative dy dx, which would be negative, dy dx was 1 at that point, minus, or plus y, which is 2, all over x squared, so negative 2 squared. So you get positive 2 plus 2, which will give us 4 over 4. So that gives us positive 1. So the second derivative is also positive. What does it tell us if the second derivative is positive? Concave up. So C would be the correct answer here. Okay, questions? All right, get rid of this. Okay. This question says consider the curve defined by. It is known. It gives us the first and second derivative because they are so nice and they're not making us find it on our own. Which of the following statements is true about the curve in quadrant 4? Okay. And if you look at the answer choices, which are on the second page, because the AP Classroom does not care about putting everything together. If you look at the answers, everything is talking about concavity. There's 2 that we can throw out before we even look at the actual answer. Look at the actual problem. What two could we throw out? A and B, because the first derivative has nothing to do with concavity. So we could throw out A and B right away. So we really just want to know what the sign of the second derivative is. So they gave you this first derivative as a distractor. You're not going to use it at all. In the fourth quadrant, which is right here, we have a positive x value and a negative y value, right? So I don't know what values I have, but it doesn't matter because the second derivative, if I have negative 81 over 16, I've got a negative y value to the third, right? It doesn't really matter what number that is right there because all we care about is the sign. So I'd have negative 81 over this. Negative to the third would remain negative. So I'd end up with a negative number right here. That negative times this negative would give you a positive right there. So second derivative is positive. So we can say there that C is the answer for that one. Okay. Questions? All right, let's look at 4. Okay, for 4, at how many points on the curve x to the 2/3 plus y to the 2/3 equals 9? In the xy plane, does the curve have a tangent line that is horizontal? So when you see horizontal tangent line, we're looking at the derivative. So dy dx. And if it's horizontal, it's going to equal 0. Okay. So we need to find the first derivative here and see where it equals 0. So to take the derivative here, we would have 2/3 x to the negative 1/3 plus 2/3 y to the negative 1/3. But we have to put a dy dx with this, and that equals 0. So I would move that 2/3 over to the other side. 2/3 y to the negative 1/3 dy dx would equal negative 2/3 y to the x to the negative 1/3. I would divide both sides by 2/3 y to the negative 1/3. Thank you, Harper. The 2/3 can cancel each other out here. So dy over dx would equal negative x to the negative 1/3 over y to the negative 1/3. You probably don't want those. You probably do not want those negative exponents here because that makes things complicated. So I would switch them back. Dy over dx equals y to the 1/3 over x to the 1/3. I guess I should keep my negative right here. And so if this is horizontal, that means we get 0, which means that the numerator would have to equal 0. So we would have negative, well, you don't have to include the negative. You can, it doesn't matter. I'm not going to. We got to the 1/3 is the cube root of y equals 0. You're just going to get y equals 0 for that. So I know y equals 0, but this is a implicitly defined function. So there could be, or actually, I shouldn't say the word function. It's not a function. So there could be more than one x that goes with that y. So this does not tell us that there's only one answer, because we got to go back up here to this problem. And so if we go back up here, I'm going to have to erase some because I'm running out of room. If we go back up here and we plug in 0 for our y, we're just going to get x to the 2/3 plus 0 equals 9. And then this is the cube root of x squared. So we could cube both sides. And right now I'm just going to leave that as 9 cubed because I don't feel like doing 9 cubed without a calculator. This is not a calculator active problem. And square root both sides. So x equals 9, the square root of 9 cubed. So if you think about that, that is the square root of 9 times 9 times 9. Right? What is the square root of 9? It's 3. So that means we're going to get 3 times 3 times 3, which is 27. Except for, I should have put a plus or minus in front of this. So I've got y could go with plus or minus 27. So that is 2 separate points for that. Let me double check. There was something weird. I think it was on the other problem though. Get this one real quick. Make sure. Yeah, that's right. Alright. 5 is just like 4, and I didn't mean to put it on the notes. I meant to put a different problem on the notes. Let's look at the homework page now. And look at number 5 on the homework page. We're not going to have time, are we? We're not going to have time. This one's a little bit long. Okay. For your homework, this homework is going to be due Friday. Tomorrow is a work day in class. You can work on your progress checks. You can work on this homework. You can work on whatever you need to work on. The progress check, all of the progress checks and the homework here will be due on Friday. So tomorrow at the very beginning of class, I'm going to do number 5 with you, and that's the only instruction I'm going to do. The rest of the time is your time to work. So if you try to do any of that homework there, number 7's like number 5 on the homework. Both of those you're probably not going to get right now. There's something really weird about them. So we'll just